Hello, let's start with the day 6 of your Android application development course. In this, we will be studying something about SQLite. SQLite is a lightweight database which is given to you with Android. All the slides in this lecture are made very carefully. So I would request you to pay a very good attention on all the slides because SQLite is a very nice concept, but it is very lengthy. So if in between you miss up a link, then you can go back and start the lecture once again. Okay, so do not miss up the link in between. Have your full concentration of what I am saying and try to understand it very carefully. SQLite. SQLite is a subset of the normal SQL database. It has the following features. First, it is easier to set up. Okay. Second, it is great for mobile databases, and Android is a mobile solution, so it is very good for Android as well. Third, it is great for rapid development. It is great for embedding inside an application. It does not have user management, that is, you don't have to have an ID and password to log into the database, because whenever you are using it on a cell phone is a single user environment wherein the cell phone will be used at the most by one user only. So you do not have to have a user ID and password to access the database. That database is completely on the cell phone for the user only. It does not have many performance features, but Android optimizes the database for us already. It does not scale well, that is, you cannot have a single database on two cell phones. You will have a single database on only one cell phone, and that is what required. And let's move ahead and see what is the Android's SQLite model, or the model of the database which will be used by us. At the first part, we'll be having the SQLite database. The database consists of rows and columns, and these rows and columns are together form a table. Okay, so one database can have multiple tables. Each of these tables can have rows and columns. For example, if you use a Excel sheet, an Excel sheet has sheet 1, sheet 2, sheet 3. The sheet 1 can be taken as one table, sheet 2 as second table, and sheet 3 as third table. On sheet 1 you have rows and columns. Normally on the columns you put the data's heading, for example serial number, name, phone number, address, etc. While vertically in the row wise you add the records. So database is similar to that. You have multiple tables. In each table you have rows and columns. Then to the SQLite database we have a database handler class. This handler class will access the SQLite database directly. Okay, so whatever operation you want to perform on the SQLite database, that will happen through with the help of the database handler class. Accessing this database handler class will be done with the help of table specific database class. For example, if in your database you have three tables, all these three tables will be accessed by a single database handler class, and you will be having three table specific classes which will be accessing the database handler class to execute queries on the three tables in the SQLite database. To give you an example, if you have tables like table 1, table 2, table 3, then you will be having three table specific classes. All these three table specific classes will be using the database handler class. The database handler class will be accessing the database directly. Then you will be having your main Java code, that is the Java code which will interact with the table specific database class. Then you will have your XML based UI. Okay, to give you an example of this, let us assume that you create a login application wherein you have a user ID or a username and password, and you have all the information about that user stored inside the database. So on the user interface you will have username, password, login. As soon as you click on login, the Java code will be called. The Java code will access the table specific class for login. This table specific class will access the database handler class. The database handler class will access the SQLite database and it will check if the user is valid or not. If the user is valid, it will give a response to the database handler class. The handler class will give the response to table specific class. It will give the response to the main Java code, and the main Java code will display something at the output. You are logged in or you are not logged in. I hope the hierarchy is clear to you. So this complete hierarchy is divided into three tiers. Tier 1 is called as the database. Tier 2 is called as the business logic or the logic of your application. And tier 3 is called as the presentation tier. Okay, so whenever you say you have a 3-tier model, the 3 tiers are database, the business logic, that is the logic of your application. Then you have the presentation layer wherein you just display the UI to the user. Okay, I hope the model is very clear to you. You have the database handler class, the table specific class, the main Java code, and the XML based user interface. Let's see how will we code the SQLite database. First of all, we'll have the database with us. It will contain data in the form of tables, that is rows and columns. Then we'll have the SQLite helper class or the database handler class. The database handler class will access the database. Okay, this will execute general purpose queries on database. Then you have table specific SQL class. This table specific SQL class will create table specific queries. For example, it will create the queries for insert, for update, for delete, and for select, and it will execute these queries with the help of the helper class. So you have the SQL database, you have the helper class, you have the table specific SQL class. The table specific SQL class will create the queries, execute the queries with the help of the helper class on the database. And then you'll have the main Java code, which will access the table specific class to access the database. Let's have a sample design of database with us. Let there be a database called as DBF cities, and let it have only one table called as TBL city information. Okay, so we have one database. Inside that we have one table called as TBL city information, and the table has 4 fields, say ID, name, code, and specialty. The ID is also called as the primary key of the table. The primary key is a unique number for each record on the table. You can assume that the primary key or the ID is the serial number of the record. Okay, as you will be adding the records, you will be adding them with different serial numbers. The serial number is the ID. It is called as primary key. It is of type integer because the ID will be 1, 2, 3, 4, 5, 6, 7, 8. That is an integer, and it must auto increment. Means what? The ID should increment automatically as you insert records. Okay. The second is the name. For example, you'll have the city name like Nagpur, the code that is 0712, and specialty say oranges. Now the classes that would be created in our case will be database handler.java. This will handle the database. Okay. Then you have DB city information. This will be used to execute queries on the table TBL city information. So see, you have the table name as TBL city information and the class name as DB city information. Okay. The DB indicates it's a database class. Then you have main Java class. It will use the DB city information class to insert, update, delete, and select. Okay. So let's see how do we use SQLite on Android. Android supports full SQLite capabilities. To create a database application on Android, the following steps must be followed. Now, after years of experience of working with the Android SQLite model, we have found out some steps that will allow you to actually ease your development with SQLite. The step 1 is you should create a database handler class to support SQL operations. This class must have the base class as SQLite Open Helper. The SQLite Open Helper class is a class given to you by Android. This class helps you to execute queries on the SQLite database. Step 2, you must create a database class for the table for which you need to operate. This class must contain queries to insert, update, delete, and select records, and it must also contain query to create the table. Okay, there is one more query to create the table that should also be inside the database or table specific class. Then you have the database class should use the database handler class to execute the queries. So you have the database handler class, and with the database class, this is the table specific class. This class must use the handler class to access the SQLite database. Then create the main Java code and access the database class inside it. Let's have some sample SQL queries. The create query looks like this. Create table if not exists. Okay, everything which is in capital letters are the keywords for SQLite. In our case, create table if not exists. The table name is TBL information. In bracket, the field name is ID, integer auto increment. That indicates ID is a field of type integer and this will auto increment, comma, name, text not null. Name is a field, text not null are keywords, comma, code text not null, specialty text not null. This indicates that in our complete table we have four fields: ID, name, code, specialty. ID is of type integer, name is of type text, code is of type text, specialty is of type text, and all these are not null. Then you have insert query. In the insert query, we will say insert into the table in bracket the field names, name, code, specialty, values, the values that we want to pass. So this will actually insert one record with the values Nagpur, 0712 and oranges inside the table TBL city information. You might have a question that why didn't we had ID over here? Because the ID was kept as auto increment. As you will add one record to the database, the ID will automatically increment from its previous value. You have the update query. It's very simple. You have update the table name, set the field that you want the values for. For example, we'll say update TBL city information, set name equals to Nagpur, code equals to 0712, specialty equals to oranges, where ID equals to the ID of the record. So I'll have ID equals to 1. Then we have the delete query. That's also very basic. Delete from table where the ID equals to 1. This ID is the unique ID for each row. So each row will have a separate ID. And we have select query. Select star from TBL information. Now this star indicates you have to select all the fields. So whenever we say select star from TBL information where ID equals to 1, this indicates that select all the fields, that is select ID, name, code, specialty from this table where ID equals to 1. So where the ID would have been 1, you have to select all the records. Over here we are saying select star from TBL information. This indicates it will select all the fields for all the records in the table TBL information. I hope the queries are clear to you. Let's create a new project and call it as SQLite demo and make the main layout to look like this. Okay, lots and lots of controls over here. Let me tell you how many controls we have on the screen. We have 4 text views: enter ID, enter name, enter code, enter specialty. We have 4 edit text: txt ID, txt name, txt code, txt specialty. We have 3 buttons: btn insert, delete and update, and we have a list view over here. This list view will be able to show all the records that we'll be inserting inside our database. So this is txt ID, txt name, txt code, txt specialty, btn insert, update, delete and the list view of electricities. Okay, now this is a linear layout which is vertically arranged. Now let's add the database handler class. Let's create a new class with the name database handler. The database handler class will have the base class as SQLite Open Helper. So we'll have public class database handler extends SQLite Open Helper. This is very important because whenever you want to access a database on Android, at that time you will be required to have the SQLite Open Helper class. Then we have public SQLite database DB. This is our SQLite database that we'll be using in our project. Then we'll have the context, the database name, and the database version. These properties are required whenever you are coding for any database. So this class will remain generic for any application that you will be creating after this using SQLite. Then you have the constructor for it. The constructor function is used to initialize the values. In this case, we have three values, that is context, database name, database version, and we have one more value for the database, that is DB. So we want to initialize all these four values inside the constructor database handler. So we'll say context equals to ctx, database name equals to db name, and database version equals db version. Then we will say db equals to this dot get writable database. Okay, this statement is very essential, because what the statement will do is the statement will get a database from this application on which we can read or write. The database handler class has some inbuilt methods which we have to have in our class as well. The first method is called as onCreate, and the second method is called as onUpgrade. These methods are called by default whenever you create or upgrade your database. You don't have to do anything over here. You have to just have these methods as blank. Whenever you create these methods, they will be used only to create and upgrade the database. Now let's have some functions which will be used to interact with the database. The first function is called as execute query. The execute query function is used for create, insert, update, and delete queries. So what we have to do over here is we have to simply say db, that is the database, dot execute SQL, the query name. So we'll say db dot exec SQL and the query. This will actually execute the query on the database db. So far so good. Then we have a execute select method. The execute select method is used to execute select queries on database. The execute select method has many properties. One of them is table name, the number of columns that you want to return, the where conditions, the group by clause, having clause, and order by clause. All these clauses are linked with the SQL language. So if you want to have a greater depth of these clauses, you can refer the SQL documentation. For our case, we'll be just keeping the table name as it is, and we'll be passing null to all the other arguments. By doing this, we are telling the SQLite database that we want all the records from this table name. We want all the columns. We don't have any where conditions, no group by clauses, no having clauses, and no order by clauses. So over here we'll have cursor result equals to db dot query. The db is the database and query will return you a cursor. Now what is a cursor? We'll see in the next slide, but for now just understand that whenever we try to select a record, we get a cursor at the output, and it takes all the parameters that we have passed over here, and that's a return result. This execute select function will be used to execute select queries on database. We'll have close database. Close database will have just db.close. It will close the database after the work has been done. I hope we are clear with this. We have just three functions: execute query, execute select, and close database. Execute query will be used for create, insert, update, and delete. Execute select will be used only for select statements, and close database will be used when our work with the database is over. Let's see what are cursors. Cursors are objects which are used to keep track of the select queries of database. To make this point clear, if you say select star from any table, you will get all the records from the table. But you cannot access all the records at one go. You will be accessing the records one by one. To keep a track of the record at which you are currently in, cursors are used. So on execution of a query with the query method, a cursor object is returned. We can use this object to move around the database. The following functions of the cursor class are much more important. The first function is called as move to first. Whenever you say move to first, your cursor will move to the first record in the database. Then you will say move next, it will move to the next record. You will say get int in the column index. So suppose your first argument was the ID. When you will say get int 0, it will get you the ID of the current record. So let's take an example. If you have a SQLite database where you are saying select star from TBL3 information and you are getting 3 records, and out of those 3 records you will say cursor dot move to first. So now you add the first record. If you will say cursor dot get int 0, it will try to convert the first column into integer. The first column in our case is an ID, which is already an integer. So you will get the ID of the first record. Then you have get string. Get string does the same as get int, but it is used for string columns. For example, name, code and specialty are the strings. So when you will say get string 1, it will give you the string of the name of the city. When you will say get string 2, it will give you the name of the specialty of the city and the code of the city. So this is the use of get string. Then you have get column index, column name. Whenever you have a column name, for example, in our case, the column names are ID, name, code and specialty. If I want to get the column index of code, so I will say cursor dot get column index code. It will give me the column index of the code column. So if you want to get the column index of specialty, you will say cursor dot get column index specialty. It will give you the column index of specialty, which is 3. These were the functions of the cursor which were very essential. Let's move towards table specific classes. Let's create a new class called as DB city information, and this class will be used to access the TBL city information table. Public class DB city information, that's very clear. We have the database handler object, database handler class have been defined by us previously. So we'll have the object of the database handler. Then we have the context, the database name and the version. We'll define the constants over here, that's the table name, the column for ID, the column for name, the column for code and the column for specialty. Why are we doing this? Because whenever we will be having a query, inside that query we'll always be using the table name. Inside the query we'll always be using the ID, the name, the code and the specialty. Okay, so if tomorrow the table name changes, then you will have to change that table name in all the queries, correct? To have a turnaround on that, what we will be doing is, instead of using the table name as TBL city information, we'll be using the function or the variable table name at all those places. So if we have to create a insert query, we'll be saying insert into table name. The table name will be this table name, and in bracket field name, field code, field specialty, and then the values of those fields. Okay, that is why we have defined all the strings as constants over here. Then we will be using these strings inside our queries directly. And let's define int ID, int string name, string code and string specialty. These will contain the values of the table. So the field name, the field code and field specialty and field ID contain the name of the columns of the table, whereas ID, name, code and specialty contain the values inside those columns. Okay, so we'll also create a create query, public string create query. We'll say create table if not exists. The table name over here will be replaced by TBL city information. Then we'll have field ID, field name, field code and field specialty. Let me explain this thing to you. The create query says create table if not exists, the table name. So whenever you will be reading this, you will be reading it like this: create table if not exists, TBL city information, plus will add a string to it in bracket, plus ID, that is field ID, plus integer primary key auto increment, comma, double quotes, plus. Now here the string ends. We have to concatenate this with the field name. So I'll have field name plus text not null, plus field code text not null, plus field specialty text not null. Now this syntax might be a bit confusing to begin with, but you have to appreciate the fact that tomorrow if the table name changes from TBL city information to TBL city info, then you don't have to change TBL city info over here. You have to just make a change once. This change will be reflected in all the queries to come. After table specific class, let's move on to create the constructor of this table specific class. We'll have public dbcity information. This is the same name as the class name. Over here we have to pass the context, the name of the database and the version. So let's initialize them. We'll say db equals to new database handler. The database handler was defined by us, and if you will recollect, inside the database handler constructor we had the context, the name of database and the version. Then we'll say db.execute query create query, because before creating an object for the city information table, we should have the table with us already. So we will first execute the create query. This will create the database for us. Then let's capture the references of the context, the database name and the database version. And let's initialize all the fields, the ID, the name, the code and the specialty to null. So let's revise what we have done. We had first created the database handler class. Inside the database handler class, we had three functions: the create, the execute query function, the execute select function, and the close database function. The execute query function was used to execute general purpose queries on database. Execute select was used to just have the select queries. The execute select function gave us a cursor. That cursor will be used to go through all the records of the database. Then we created the dbcity information class. Inside this class, we defined the database handler object. We defined all the fields. We defined the table name and we defined the values of the fields. We had created the create query, that was create table if not exists. Then we had the constructor for the dbcity information class. Inside this constructor, we created the database handlers object and we executed the query to create the database, which was the create query. We got the references of the context, the name and the version, and we initialized all the fields. After this, we'll have the insert query. So we'll say public void insert. Insert query is very easy. We'll say insert into the table name, field code and field specialty, values. Now the field name is a string, so the string will be in a single quote. So we'll say before name we have to have a single quote. So see, we had double quotes, bracket close, values, bracket open, single quote, this is the single quote, then double quote close plus name plus double quote open, single quote close. Okay, this single quote open was for the name, the single quote close will close the value name. Similarly, code was also a string, so we'll have in single quote code, single quote close, then a single quote specialty, single quote closed, and then semicolon. This creates the insert query. To execute the query, we will simply say db.execute query, insert query. We simply have the update query as well. In the update query, it's very easy. We will say update table name set field name, this will be replaced by name, equals to, as name is a string value again, so we will say set field name equals to single quote the name, single quote close, comma, field code equals to single quote the code, single quote closed, comma, field specialty equal to single quote specialty, single quote closed, where field ID equals to ID. As field ID is a integer, so we will not require a single quote over here. So we'll have straight away field ID equals to ID. Then we have the delete query. It's very easy. We'll have delete from table name where field ID equals to ID. Then we'll execute all the queries. Okay. So whenever we'll call insert, the insert will be called, update and delete. The three queries will be called and you will be able to get the output. Let's try the select all query. In this query, we'll be selecting all the records of database. All the selected records must be stored inside an array list. Okay, we'll be having an array list. Inside that, we'll be storing all the records. The array list should then be returned from the function. Okay, let's do that. We have public array list of DB city information. This indicates that the select all cities function will be returning us an array list containing objects of DB city information. Then we'll have a cursor. The cursor will be required to get all the records from database. So we'll say cursor result equals to the database dot execute select. Inside the execute select, we'll have the table name, that is the table from which I want all the records, and I will pass null for all the other arguments because I don't want to have any where conditions, any order by clause, any group by clause, etc. Then we will say, let's create a new array list of cities by saying array list db city information lst cities equals to new array list. This indicates that we are creating a new array list of type db city information. Then we'll say if result.move to first. This indicates that we have at least one record in our database. If result.move to first gave us a true value, then we'll create an object of the db city information. We'll have a do while loop. Inside the do while loop, we'll first create a new object of db city information. We'll say obj city equals to new db city information. Inside this, we'll pass the context, the database name and the version. Because the constructor of this class requires us to have the context, the database name and the database version. Then we'll set up the fields inside this by saying objcity.id, this is the object of city.id equals to result, that is our result or the cursor, dot get int. Because the id is an integer, we'll get the int of it. We can simply say get int of 0. This will also work, but we have to be sure that whatever get int should have, it should have the actual index of the column. So we will say result dot get column index. Which column index? The field id is column index. So result dot get column index field id will give us the column index of the id field. From that column index, we'll be passing the column index to the getInt function. The getInt function will take that column index and give us the id of the result. Similarly, we'll do it for the same for name, code and specialty. In name, we'll say objcity.name equals to result.getString, because name is a string, so we say result.getString. Inside this, we have to pass the id from where we can get that name. So we'll say result.get column index field name. It will get us the id of the field name. From that column index of field name, we will get the string and we'll put that string inside the objcity.name. Similarly, we'll say objcity.code and specialty. Once the fields are set up, we will add this object to the array list by saying lstcities.add objcity. Okay, so we created a new object of type dbcity information and added this object inside the array list. Once we are done, we have to move to the next record. We will say while result.move to next. The result.move to next function will return you a true value if the next record is present. It will return you a false value if there are no more records present. So if there are 5 records, this loop will run 5 times, and after the 5th record has been passed, this while will return a false and will give you the output to be out of the loop. Okay, then you will say return the array list. It will return you the list of cities in the form of an array list. So far so good. Now when you want to select a single record, you have to understand that every record will have a unique ID. To select a record, we must get the ID of the record, then execute a select query with this ID. The selected record must be stored inside the object calling the query. Okay, for example, if we create a new object of dbcity information class and name it as objcity information, we would set up the ID of this object by saying objcity information.id equals to 3. Then we would call objcity information.select city function. The information about the city with ID 3 should be stored inside this object. Okay. So with that knowledge, let's complete the dbcity information class. So we'll say public void close database and we'll say db.close. Okay. that was the last function of closed database. We have to also override a function called as toString, because we will be adding the object of the array list inside the list view. Whenever we add the object of array list inside the list view, then we have to call the set adapter function. The set adapter function will call the toString method of each object inside the array list, and whatever you return from toString will be displayed on the list view. Okay, let me reiterate that once again. We will get all the information of the city inside an array list. We will be adding this array list inside the list view. When we will add the array list inside the list view, at that time the list view will call the toString method of each of the objects of this array list. So whatever we write inside the toString method over here will be displayed inside the list view when we call it. Okay, so we want the output to be looking like ID plus comma plus name comma code comma specialty. So if the ID of Nagpur city was 6, the record on the list view should look like 6 comma Nagpur comma 0712 comma oranges. Okay, I hope we are clear with this. Let's write the SQLite demo class. This is our main activity class. So inside this we will have the database name and database version, because we are on version 1 of our database, so we'll keep the version as 1. Let's override the onCreate function. Inside this we have the set content view or layout main. Okay, this is the default code which we already have inside our onCreate function, and this is the code that which we have added, the database name and the database version. Let's get the references of the controls. We have many controls, so let's get the references of them very quickly. We have the edit text of ID, the name, the code, the specialty. We have insert, update, delete, and we have the list view for cities. Okay, let's initialize the list view at activity launch. Whenever the activity is launched, at that time we want all the information of the city inside the list view. Thus, we would fill the list view with the previously recorded stores that we have in the database. So, if you have information about 5 cities in the database, all that information should first come from the database on the list view whenever you are starting the activity. Okay, for that we will create a new object of the DB city information. With this object, we will be passing the context of the application, that is this, comma database name, comma database version. Then we will create an array list by saying array list DB city information ARR cities. To this array list, we will get all the objects from this obj city information. So we will say obj city information dot select all cities. The select all cities function gives you a list of all the objects of all the records in the database in the form of an array list. That array list is ARR list cities. Now we will make the adapter of the list view to this array list by saying lst cities dot set adapter new array adapter. This array adapter is not of string. This array adapter is of DB city information. The first argument is the context. In our case, this will be main activity dot this. In this case, it is SQLite demo dot this, comma android.r.layout.simplest item 1. This is the layout which will be stored, comma the list of cities that we want to display. So this ARR list cities contains all the objects. For all the objects, the toString function will be called, and you will be getting all the records separated by a comma. Okay, let's write the insert button handler. So we'll say btn insert dot set onClick listener, new onClick listener, public void onClick. Over here we'll first create an object of the DB3 information class by saying new DB3 information. Once that is done, then we will be getting the ID. The ID is an integer, while the ID that you get from the layout is a string. So we have to convert from string to integer. That is being done with the help of integer.parseInt. We'll get the name, we'll get the code, and we'll get the specialty, and we'll say obj city.insert. Once you insert this, at that time, because there are some insertions going inside the database, you want to reflect all that insertions inside your list view. To do that, you will be actually clearing the fields first, then you'll be getting all the records from database by saying objcity.select all cities. Once you get all the records, then you will simply set the adapter of the list view to the array list as we had done in the previous slide as well. Okay, we'll show the toast to the user that the database has been properly populated and your record has been inserted in the database. In case there is an exception, we'll toast that exception out to the user. I hope this is clear to you. This is a bit lengthy, but as you will code the steps, you will be able to get the concept behind it. That for insert, we are filling all the fields, then inserting that field inside the record, then clearing all the fields and getting all the records from database and displaying them at the output. Similarly, let's select handler. When a user select an item from the list view, all the details must get filled inside the form. Okay, so when you have a list view and the user clicks on one of the cities of the list view, at that time all the records from that list view must be inside the form. For example, if I click on the Nagpur's record, then all the details of Nagpur must be filled inside the form. The data inside the list view is displayed in the following format: id, name, code, specialty. This is due to the toString method that we have already seen. To get this data, we need to override which function? On item click listener. Each item obtained will be then splitted by a comma. That is, we'll split the item with a comma. By splitting that with the comma, we'll get 4 fields. That is the 4 elements of the array. Out of this, the ID is present inside the 0th location. Name is inside the first, code inside second, and specialty inside third. So we'll say lstcities.set on item click listener, and when someone clicks on the item, we'll get the required item from there. We'll get the string on the required item and we'll split the item with the help of a comma. So as we'll say str.split, whatever item has been selected will be split with the comma, and you will get all the records, that is the ID, name, specialty and code inside the data. Now we have to do a simple thing of filling the complete fields by saying txt_id.setText data of 0. This data contains all the 4 fields. Out of these 4 fields, you will require the 0th field, that is the ID, first field the name, second field the code, and third field the specialty. In case there is an error, you just toast that error to the output. Once you are done with writing the select handler, we'll write the update handler. So btn update.set on click listener. On click, you'll get all the fields, ID, the name, the code, and the specialty, and you will say obj.update. Okay, this will update it. You will toast at the output that this has been updated, and you will update the list view as well. Okay, so far so good. This is basically the repetition of the previous insert handler, but over here we have just created the update handler and done everything as same. The delete handler is very easy. You will have to get the ID, create the object, fill the ID, and say delete. It will delete the record from database. Now after deletion, you also want this to be reflected in the list view, so you will update the list view as well, as we have done in the previous slides. Okay, this completes the SQLite session. The SQLite is a very good database that you can work with. We have shown you an example with a single table. What you can do as a assignment problem is, you can have multiple tables in your database and you can try to access all those tables with the help of the SQLite Open Helper class. Let's do it for the SQLite database. The SQLite database codes are very big, so we have already developed them for you. I'll be showing them to you in a very systematic manner. First of all, let's go to the layout and see the layout of the SQLite demo. The layout contains the following controls. It contains the ID, the name, the code, the specialty, the buttons, and the list view. Let's go to the package and open the database handler class. Inside the database handler class, you have the SQLite database. The class extends SQLite Open Helper, and you have the context, the database name, and the database version. Then you have the database handler constructor. In the constructor, you are taking the reference of the context, the database name, and the database version. Then you are getting the writable database from the SQLite framework. You have onCreate and you have onUpgrade. These two functions are left blank because we don't want to do anything when the database is created or upgraded. Whenever someone says execute query, this will execute one query, which is insert, update, delete, or create. This will come over here. When someone passes the select query, he has to pass it to execute select. Whatever execute select will execute, it will give you a cursor. You will return this cursor with the help of db.query. The closed database will close the database. Then we'll be using this database handler class inside db3d information. Over here, we have kept the table name, the field ID, the field name, the field code, and the field specialty. We have defined the values for this by ID, name, code, and specialty. We have had the create query string. The create query says create table if not exist, the table name, field ID, integer primary key auto increment, the field name, the field code, and the field specialty. In the constructor of db3d information, we are first getting the database by saying db equals to new database handler. Then we execute the query on this database by saying db.execute query. We'll capture the context, the database name, and the version for future use. Then we will initialize all the fields, that is the ID, name, code, and specialty. Inside the insert function, we'll be having the insert query, that is insert into the table name, all the fields and the values. As you can see clearly over here, the field name is a string, so we have values, single quote open, the string is closed, plus name, and single quote closed. Okay. Similarly, the code also is a string, so we have a single quote over here. Similarly, specialty is also a string, so we have a single quote over here. Moving along, we have the update function. Update function is the same. Wherever we have update table name set, field name equals to in single quote the name, field code equals to in single quote the code, and field specialty equals to in single quote the specialty, where ID equals to the ID. Now ID is not a string, it's an integer. That is why we don't have a single quote over here. Similarly, for the delete query, we have delete from table name, where ID equals to the ID. Over here, ID is an integer, so you don't have a single quote, you have it directly. Then you have select all cities. In select all cities, you will execute the select on the table name. You will get the list of cities. Out of this, you will say if move to first, then you are on the first record. You'll create a new object. You'll fill in all the properties of the object, and you'll add the object to the list view or the array list, and you will be returning this array list from the function. So far so good. Then you have SQLite demo.java. In this, we get the references of all the controls. We define the database name and the database version. We create the object of the city information class. We create an array list for that, and we fetch all the cities from the object inside the array list, and we set the adapter of the list view to be of the array list type. So in this case, the toString method of the array list will be called, of this class will be called, and you will be getting the functions or the records in a comma format. So we have ID, comma name, comma code, comma specialty. Similarly, when someone clicks on insert, we will get all the information about the data and we'll insert the data. We'll make all the fields as blank, and we will get all the new records from the database and fill those records inside the list view. Okay. Over here, we don't require the ID, so you can safely comment this out, because whenever you'll be inserting, the ID will be automatically incrementing. When you say update, it will say update on that. When you will say delete, it will delete the record. And whenever someone clicks on the item of the list view, then you will get the item in the form of the text view. You will convert that to a string. You will get the data by splitting it with a comma, and you'll fill that data inside the fields of the record. Let's try to run this thing and check the output of it. Right click, run as Android application. Let's come to the emulator. In the emulator, as you can see, there are no records right now. If I'll add a record, say Pune, let's add the code of this to be 022. Let's add, or 020, sorry, and let's add the specialty of this to be, say, IT Park. And let's insert this thing in the database. As you can see, the database has now been filled with 2 Pune 020 IT Park. When I click on it, the record will be coming over here. Let me change the code of Pune from 020 to 91020, where 91 is the code of India. And let's update the record. As you can see, the record will be updated. Let's add one more record over here with the name, say, Mumbai. Let's change the code of this to 022, and let's change the specialty of this to locals. Mumbai is famous for many things, but one of them is locals. So let's make it locals and say insert. It is inserted. If you will just drag it up, you will be able to see that you are getting the two records, Mumbai and Pune. Now if I'll add one more record over here, say Nagpur, add the code of this as 91712. The specialty of this as oranges. Okay, let's insert it. You'll be able to get oranges as well over here. Let me remove the city Pune from here. I'll just click on Pune and then delete. I'll delete it and it'll give me the two records, that is Nagpur and Mumbai. Even if I come back off the application and come back in again, then too I'll be getting all the records, because these records are stored permanently on my cell phone for a lifetime until I don't delete it.